Okay, last session before lunch, and I would like to remind you during the lunch, if you want to check out the Dome Theater, do that, because it's the last chance during lunch. But first, before that, we have Anne B. Nielsen, who's gonna talk to us, so go ahead.
Yeah, thanks. We're actually a little bit ahead, but I don't think there will be so many more, maybe. But okay, hello, my name is Anna. I'm a chief engineer in the geomatics department at NIBIO in Norway. I would say I'm quite stable and perhaps static, since I've been working at NIBIO for the last 23 years. So, and I started with the software of which we don't say loud, QGIS, in the mid-90s. But then I detected QGIS in June 2010. And to quote Frank Sinatra, ever since that night we've been together. So today I will show you how you can use QGIS to organize and to validate large data set quickly and efficiently. So it's another total subject than the two previous presentations. But first, a few words about NIBIO. NIBIO, we conduct research and supplies knowledge about food, plant production, the environment, maps, land use, gene resources, forestry, and economics. And we are around 750 employees spread across 15 locations from north to south, with Ås as our head office, just outside Oslo. And in NIBIO we use open source software to a great extent, and QGIS is now the main desktop GIS software. And I myself use QGIS to a variety of tasks, and today I will show you how you can use QGIS effectively for checking your map quality regarding classification. When we check a map, the evaluation follows three main steps. First, we zoom out and pan around to get some kind of an overall impression. And then next, we zoom in to areas. Maybe we know the areas, so we take a look and we feel to get a better impression of the quality. And then finally, we do the statistical assessment. Green areas, as you may know, have many different functions. They absorb and delay precipitation. They are important for biodiversity, and they help regulate temperature. In addition, they are important for recreation and public health. So NIBIO has developed and launched a new map called Green Structure Map, covering vegetated areas within built-up areas, including a 50-meter buffer. And this green structure map is created from very high resolution images from the Copernicus data space ecosystem with 2 to 4 meters resolution, and National Digital Surface Model with 1 meter resolution, and existing detailed datasets with roads, agriculture, buildings, and water. And based on these input datasets, the surface is classified into 8 different objects or classes: field, bush, tree, gray, road, agriculture, building, and water. And what we wanted to do, we wanted to check the quality of this map. How good is the classification of the 4 top classes: field, bush, tree, and gray on a polygon level. And how do we do that? How do we check the classification? Well, in Norway, we have a standard called geodatakvalitet or geodata quality, quite similar, which is based on an international standard, ISO, standard called Geographic Information Data Quality. And the geodata quality standard covers how to describe, check, and report the quality of spatial data. So we followed the standard and created a plan for the evaluation. Said with standard terminology, we want to check the thematic accuracy as thematic classification correctness. We want to check the classification of the 4 classes, field, bush, tree, and gray. And this is done by comparing the classified polygons with orthophotos and the digital surface model from approximately the same year as the input datasets that we use to create the green structure map. Then the question is, how many polygons do we need to validate to be statistically significant? First, we found the total number of polygons in each class just by using the feature count in QGIS. And based on these numbers, we go to the geodata quality standard, and it reveals the necessary sample size. 1250 in our case, and that was for each class. And then next, we randomly selected 1250 polygons for each class and saved the samples in different layers in GeoPackage files and loaded them into QGIS. And then the fun part begins. Then we have to check and evaluate 4 times 1250 polygons. And then the comparison resulted in statistics showing the percentage of wrong classification. So to do the evaluation quickly and efficiently as possible, we somehow customized or adapted QGIS in advance. And some of these adaptations or perhaps recommendations may be known to you, some of them may not. Nevertheless, in the next slides, I will briefly give you the steps on how you can set up your QGIS for visual validation of a map. The first step is pretty basic and straightforward. You load all your needed layers and you organize them in themes. You just then select or check the layers you want together in a theme. Choose add a theme and give the theme a suitable name. And in my case, I created 2 themes. One theme showing the transparent green structure map above orthophotos, and then one theme showing the digital surface model and its year of origin. I think it's been in QGIS for quite some time, but I think I detected it just a year ago. And this is a very nice and convenient feature in QGIS, where it's possible to have several map canvases. So you add a new map view, you change the name and settings to your likings, and then you set the desired map theme. Then you have 2 synchronized map canvases. So when I move the cursor in the main window to the left with the green structure map, the cursor will move accordingly in the right map view with the surface model. As I mentioned earlier, according to the standard, the sample size of the polygons are 1250. That's a rather large number of polygons to go through. So we divided the task between me and another colleague, but still I had to check 635 polygons, and this was to be done for 4 classes. So to quickly move from one polygon to another, we used the plugin Navtable. This is a very nice plugin that saved us a lot of time. First, you choose the layer or the objects you want to check. In my case, here I want to check the tree polygons. Are they correctly classified? Meaning, does the tree polygon actually contain trees? After that, I activate the Navtable plugin. I choose Pan, and then I can go to the next polygon with the right arrow button, the button with the large symbol. And a tip, in order to sorry, that was a little bit too fast. In order to avoid, or if you have to click through 1250, or in my case 635 polygons, a tip is to order the polygons ascendingly, because it makes it easier for you to keep track on how far you have come when you need a click break. I mean, you don't want to get a mouse arm. I think it's called in English as well, musarm. So and then it's makes it easier to stop that. Now I have reached 50. I go for a break or whatever. And another thing is, when preparing the sample layer, we added a new attribute called deviation, or as it says here in Norwegian, avvik, and set the value to 0, meaning the classification is correct. By setting the deviation to 0 as a default for all polygons, you will save a lot of time, especially when you suspect more than 50% of the polygons to be correct. In addition, we had 3 other codes. We had code 1 for wrong green class, also internal green class. For instance, a polygon is classified as bush, but should have been a tree. And then we have code 2 for totally wrong. You say gray, but it should have been a green class, like field, bush, or tree, or opposite. You say tree, but it should have been gray. And then finally we have the code 7, if the control is not relevant or possible. It might be a construction site or a new building. Yeah. Now it's easy and fast to compare the classified polygons with orthophotos and the surface model. We simply walk through all polygons and decide whether there is a mismatch or not, just by clicking on the arrow button. And if the orthophoto and the surface model show the same class, the classification is correct, and we do nothing and just move on to the next polygon. So, as you see, setting default to 0 save you a lot of time. Most of the time we just had to spend a small second waiting for the surface model web map services. I mentioned it before, the green structure map is created from a surface model, and the surface model is dating from approximately 2010 to 2021, and from very high resolution images dating 2021. And this may cause mismatch between newer orthophotos and the older very high resolution images and surface model used to create the green structure map. So if a mismatch appears, like shown here to the right, is it not your left? Yeah. The yellow and the green and the purple polygon. yeah, the question is it field or is it trees? Then you have to make some further investigations. So in the left map view, you have an orthophoto from 2022 showing field, while the green structure map from 2021 shows trees. So, and in the right map view here, the green structure map is based on a surface model from 2015. So, and shows trees. So the question is, have there been any real changes that have not been captured due to the old surface model? Perhaps the forest was clear-cut after 2015. And then does an older orthophoto than the one from 2022 confirm the trees in the green structure map? In Norway, we have the possibility to load all orthophotos in an area through a self-developed plugin in QGIS. And since it's a plugin in QGIS, the source code is available, so you may adjust it so you can be used with a similar image service in your country. Basically, you just have to replace the API URL for where to find the images. But by using that plugin, we can upload the images, in this case from 2015 to 2022. And we got lucky. There is an orthophoto from 2015 and also from 2017, and they both confirm the trees in the surface model from 2015, and thereby we know that the green structure map is correct. And then in the next version of our green structure map, these trees will be replaced with field. So, and after the validation in QGIS, we use the deviation code, the column to the right, to calculate the percentage of wrong classification. And perhaps you're eager to know the conclusion. The conclusion is that the tree polygons are mostly correctly classified and the gray areas are the most difficult to classify. So I just want to mention that, as you all know, I presume all of you are using QGIS, and you know it has a tons of functions. But still, sometimes you think maybe that the tool is missing, but it's missing seemingly, because someone may already have made a plugin to do what do you want to do. So this means you can benefit from the work of others. And in that case, please appreciate the time and work carried out by a fellow QGIS user by simply rating the plugin, especially if you think the plugin is good or even great. In this case, with the nav table, more than 4,800 downloads should result in more than 11 votes. Don't you think so? Just a reminder. So if you benefit from a plugin, please rate it. So, as demonstrated, by using QGIS, we can organize and validate large datasets like the green structure map quickly and efficiently. You make a plan for carrying out the map validation, prepare the datasets, and take advantage of the possibilities in QGIS. Use themes, multiple map views, and the nav table plugin. Yeah, this was a brief glance into the way of utilizing QGIS, perhaps to something else than the usual GIS task. So hopefully I have inspired you maybe to use QGIS to something else and to explore and extend the use.